Part 2, this one is for question 7 to 11. Question 7 is coming from series. The first and second terms of an arithmetic progression are, but we have then trigonometric functions, okay, respectively, where theta ranges from 0 to pi over 2. Then part A, show that the common difference is this one here. Okay, so the first term we have seen, the first term A is 1 over cos squared theta. And then the second term is A plus D, which is equal to this negative tan squared theta, then out of cos squared theta. So meaning D is equal to negative tan squared theta, negative tan squared theta out of cos squared theta. But then A is this one here, so minus 1 over cos squared theta. Now we are going to simplify this using identities in trigonometry. So here we are having the same what? Denominator. So you will have negative tan squared theta, then minus 1, then out of the cos squared theta. Now, what next? We are going to have this one is the same as sine squared over cos squared also. So we shall have sine squared theta out of cos squared theta minus then the 1 here, and then we have over cos squared theta. So we shall say this one times that, you have negative sine squared theta over cos squared theta. Then there is a minus cos squared theta here. Then times, there is a denominator here, 1 over cos squared theta. Okay, now this one here, I can see minus 1 is common. So suppose I factorize it, then we shall have sine squared theta plus cos squared theta. And this is the Pythagorean identity in trigonometry. You know, sine squared and angle, then plus cos squared and angle, then will give us a 1. And then these two will multiply, then we have cos power 4 of theta. So we shall have negative 1, then times the 1 here, which is a negative 1, then out of cos power 4 of theta. And that is our answer here. Part B, find the exact value of the 13th term when theta is equal to pi over 6. Now our first term was given as, it was given as 1 over cos squared theta. So let us find 1 over cos squared theta. So it's the same as saying cos of theta, okay, then you square it. So this is 1 over cos of 30 is root 3 over 2. So we square it, then we shall get 1 out of this is 1 out of 3 over 4, then somersault this one here, then we shall get 4 over 3. And then our common difference is negative 1 out of cos power 4. So we shall have pi over 6, then power 4. This is the same as negative 1 out of, again, root 3 over 2, then to the power of 4. So this one is the same as root of 3 over 2, then squared, and then squared, okay, for this one to give you what? Power 4. So already we have seen that this one is 3 over 4. So we shall have negative 1 out of 3 over 4, then squared. So this will be a 16, and then this will be a 9. So we shall get negative 9, no, negative 16 over 9. So they want us to find the exact value of the 13th term. So 13th term will be equal to A, then plus 12D. So we have our A as 4 over 3, and then our D as negative 16 over 9. So when we put this in the calculator all together, what do we get? 4 out of 3, then plus 12 into negative 16 out of 9. So this one gives us negative 20. Negative 20. As simple as that. Question 8. The equation of a curve is this one here for x greater than negative a half. Because when x is negative a half, you will have a 0 here. Then you will get this function undefined. Find dy dx. Okay, so our y here, and we also need to find the second derivative. So the moment they tell us to find also the second derivative, that means they will somewhere ask us about the stationary points and also their nature, because we use the second derivative to find the nature of the stationary points also. This one will be 2x then plus 1, then plus, this is 2x plus 1 using the rules of indices. When I take this one up, it has power 1 here, then it will go up, and then the power becomes what? A negative also. Now what will be our dy dx? This one will be, when you differentiate this one, you get a 2. When you differentiate a constant, it disappears. Put this one here, you have negative 1, then times the 2x, then plus 1, then reduce the power by 1, that will be a negative 2, then times the derivative of this will be a 2 using the chain rule, not so. So that means our dy dx then is going to be 2 times the negative 1, that one will be a negative 2, so we shall have 2, then minus, in fact, let me write this one here like this. My dy dx will be 2, then minus 2, out of, take this one down using rules of indices, it will be 2x, then plus 1, in brackets squared, like that. Now, we need to get the second derivative. So the second derivative, we differentiate what we have differentiated already. Okay, so we shall have to differentiate this 2. Of course, that one will be a 0. Okay, now here there is this 2 times the negative 1, that is a negative 2 already there. Then times, now drop this power, it will multiply down here, negative 2, then 2x plus 1, and then you reduce this power by 1, it will give us a negative 3. Then again enter inside and you differentiate this one here, you'll get a 2. So meaning my second derivative is going to be, this one is a positive 4 times 2, that is 8. So we have 8, then take this one down using rules of indices, so we shall get 2x then plus 1, then to the power of 3, and that is that. Okay, now you see part B, they are saying find the coordinates of the stationary point. So here we are supposed to use the dy dx, we equate it to 0, and determine the nature of the stationary point. Then we use the second derivative. So for stationary points, we know that dy dx is always equal to 0. So our dy dx is 2 minus 2 out of 2x plus 1 squared. Then we equate this one to 0. That means I will have 2, which is equal to 2 over 2x plus 1, then squared. Then we can cross multiply. We have 2 into 2x plus 1 squared, which is equal to 2. Divide all through by 2. We can have then our 2x plus 1 squared, which is equal to 1. Then take the square roots on both sides. We shall have 2x plus 1, which will be, this one will give us plus or minus 1. Now take the one this side. You have 2x, which is equal to negative 1, then plus or minus 1. Then x will then be negative 1 plus or minus 1 over 2. So these are 2x coordinates, but here they said x has to be greater than what? Negative a half. So when we go back and we check here, the two x values are going to be x is equal to -1 minus 1 over 2. What do you get? -3 over 2. No, what is this? This one is -1. Now, -1 is smaller than -0.5. So this one, we shall reject it. Okay? We shall take x, which is equal to -1, then plus 1, which will be a 0 over 2. So this x is going to be what? 0. So then what will be the value of y? You go back here and then you substitute in here. So when we substitute here, we shall get this is 2x plus 1, then plus 1 over 2x plus 1. Okay, 2x plus 1, so 2, then the x is 0, then plus 1, then plus 1 over 2x plus 1. So here we are having a 0, then a 1, and then this one goes, then 1 over 1 is 1, so we shall get 2 altogether. Okay, we shall get a 2. Then that means that the coordinates of the stationary point will be 0 and then 2. That is that. Okay, then to determine the nature, we need to find the sign of the second derivative. So for x is equal to 0, okay, this x coordinate we have gotten for x is equal to 0, the second derivative here will be equal to, remember we got it as 8 out of 2x plus 1 cubed, not so? So where there is x, we can put a 0, so 2, 0, then plus 1, and then cubed. Of course, it will be 8 divided by 1, because 1 cubed is 1, and then you get 8. This 8 you have gotten is a positive value, which is greater than 0. That means the stationary point is going to be minimum. So we just say hence minimum, as simple as that. Question 9 is coming from circular measure. In the diagram, arc AB is part of the circle with center O and radius 8 centimeters. Arc BC is part of a circle with the center A and radius 12 centimeters, where AOC is a straight line. But find the angle BAO in radians. BAO in radians. Now, for a triangle that is not right angled, okay, we use sine rule or cosine rule. If you see a triangle that is right angled, then you can use the two principles. The first one is Pythagoras theorem, that is if only the sides are involved, and then if there is the involvement of an angle, then we can use SOHCAHTOA. Okay, now since these three sides are given, okay, then to find this angle we can use cosine rule. Okay, so we shall have, this is the angle here. So you look at the side that is opposite to it, that is 8. So we shall have 8 squared, then is equal to this squared plus this squared. So 12 squared plus 8 squared, then minus 2bc. So 2 times this times that, 12, then times the 8. And then cosine of the angle that is opposite to this side here, okay? So cosine of theta. Now, here I've used the cosine rule. So to be systematic, I'll say using cosine rule on triangle OAB. Now, I need to make cos theta the subject of the formula. So since it's a negative here, then I'll bring it this side such that it becomes a positive, okay? So what is the whole of this together? 2 times 12 times 8. 2 times 12 times 8. That is 192. So we shall have 192 cosine of theta. Then it will be 144 plus the 64 for this one here, okay? Then bring this one this side minus the 64, okay? So of course 64 and 64 will disappear. So that means cosine of theta then will be 144 out of 192. So our theta will then be the arc cos of 144 out of 192. And then your calculator here must be in radians. Okay, calculator in the radian mode. So that is that. So what do we get when we put this one in the calculator? So my calculator here is in degrees, so I'll press shift that mode, and then radians is option 4. Then I'll press shift cos to get the arc cos, then 144 divided by 192, and then the answer is 0.722, and the rest of those figures, but then to three significant figures, I can have 0.723, 0.723 radians, and then this is to three significant figures. That is that. But be find the area of the shaded region. Now, to find area of the shaded region, by looking at what is here, I'll get area of this sector, ABC, minus area of the triangle. You see that? So shaded area is equal to area of sector. The sector is ABC, then minus area of the triangle. The triangle is OAB. Now, area of a sector, you know it is a half r squared what? Theta. So what is the radius? When you go and you check again here, the radius is this 8 here. Okay. Is it 8? No. It is 12. So from A to B, that is the 12. So even A to C is also 12, because this is the arc. So this arc here has this radius equal to this. Okay. So it is 12. So we shall have 12 squared, and then the theta is the one that we have gotten. So I'm going to use the exact value, which is the arc cos of, was it 144, then out of 192, not so, not just the rounded figure. Okay, then next, minus a triangle which is not right angled. Its area can be got by, if you know this side here and then this other side and then the included angle, then the area is going to be a half, then AB, then sine of the angle in between them. You see that? So we are going to have a half, then we have the two sides of the triangle, we have the 12 and then the 8, then we have the theta, not so. So we shall substitute here and say a half times 12, then times 8, and then sine of the angle, which is the arc cos of 144 out of 192, like that. So I'm going to put everything in the calculator, and then I get the answer at once. Remember, the calculator has to remain in radians. Now, 12 squared is 144. 144 divided by 2, that will be a 72. Then we have the arc cos of 144 out of 192. Okay, I'll close that. Then minus 12 times 8, I think that is 96. 96 divided by 2, that is 48. So we have 48. Then sine of the arc cos of 144 out of 192. I'll close this bracket, then I'll close that for sine also. Then we shall get our answer as 2.3 to three significant figures. So that is 20.3. This one will be in centimeters squared to three significant figures. I've written centimeters squared, but are units given in centimeters here? Yes, they're given in centimeters, so area will be in centimeters squared. Then part C, find the perimeter of the shaded region. Perimeter, we look at the lengths of the lengths surrounding the given shape. Not so. So we need to find OC here. Then the length of this arc BC, already this one is known. Okay. Now, this one here is 12. Not so? It is the radius of this arc here, like I said before. Then minus the 8, then we shall be in position to get the 4 here. Not so? And then to get the length of the arc, it is r theta. Now, let's go. So perimeter of the shaded region, perimeter of the shaded region, this one is equal to, we have seen which parts do we have. We have the OB, which is 8. We have the OC, which is 4, and then the arc BC. OB, OC, and then arc BC. So we shall have OB, then plus OC, then plus the length of the arc BC. Now what is our OB? When we check again here, our OB is 8, then our OC is 12 minus the 8, which is a 4, right? So I will say that OB is 8, then OC is 12 minus the 8, which is a 4, right? Then plus the length of one arc is given by r theta, so our r is 12, and then the theta is the other arc cos of 144 out of 192. So putting everything in the calculator, what do we get? Remember, your calculator has to remain in radians. So we have 8, then plus 12 minus 8, that's a 4. Then plus, this is the 12, then the arc cos of 144, then out of 192. And then what do we get here? This is 20.7 to 3 significant figures. 20.7 centimeters to 3 significant figures. And that is that. Question 10. A curve has this equation where x is greater than 0 and k is a positive constant. Part A, it is given that x is equal to a quarter. The gradient of the curve is equal to 3. Okay, so when x is equal to a quarter, the gradient is 3. Find the value of k. How do we get the gradient of a curve? We use a process of differentiation. Okay, so dy dx will be equal to, drop the power, we shall have 1 over k, then times a half, then x, and then you reduce the power by 1, so it becomes negative a half here, then plus, differentiate here, drop the power, so we shall have negative a half, then x to the power of negative a half minus 1, that will be negative 3 over 2. Okay, then this one is a constant, so it disappears. Okay, that is that. Now we shall have, this will be 1 over, this is 2k. Okay, then this one will go down, and then we shall have x to the power of what? A half. Then minus, now here, we shall have 1, then out of 2. When this one goes down, then we shall have x to the power of 3 over 2. Then I will equate it to what? To 3. You see that? Then after that, what are we going to do? We are supposed to solve this equation. Okay? In fact, let me first leave it like this. And then they say that for x, which is equal to a quarter, then the gradient is 3. So dy dx will then be equal to 3. So you put a quarter wherever there is x. So we have 1 over 2 of k, then times a quarter here, power a half, then minus 1 out of 2, then we have a quarter, and then power 3 over 2, then we equate this one to 3. Now square root of a quarter will give us a half, So you have a 2, then times the half, you'll get a 1. Then that means here we are remaining with 1 over k. Then how about here? You have a 2, then times square root of a quarter will give you a half. Then you cube, that means you have 2, then times 1 over 8, which will be a quarter. So you have 1 over a quarter, which will be a 4. You see that? So here we shall get a 4, then which is equal to 3. Then take this one this side, it will become a 7. So 1 over k will be equal to the 7. Then we cross multiply, that means our k shall be equal to 1 over 7. That is that. Part B, it is given instead that the integral of the whole of this is equal to 13 over 2. Find the value of k. Okay, so when we start the process of integration, you take away the what? The integral sign. So I will now replace it with the square brackets. Now increase the power by 1. So we have 1 over k, then x here is now power 3 over 2. When you increase a half by 1, you get 3 over 2. Then you divide by that new power. Then plus, you have x here. When you increase it by 1, you will get a half. Then divide by that new power. Then plus, here we are having 1 over k squared. There is an x to the power of 0 that is silent. So you increase the power by 1, then you divide by that new power. Not so? Then what else do we have? It will be 1 over k squared, then x. Then we put the limits, k squared, and then a quarter k squared. Then this one will be equal to 13, then out of 12. You see that? Now here I have 1 over k, then times the reciprocal of this 2 over 3, the reciprocal of this 3 over 2. So that means here I'll get 2 over 3k. So let me first simplify this. I'll have 2 over 3k, then x to the power of 3 over 2, then plus this one will somersault, and then we'll multiply with the x power half here. So we shall have 2, then x to the power of a half, and then plus 1 over k squared x. And then we put our limits, k squared, and then 1 over k squared, which is equal to 13 over 12. Now let us put the limits. So we shall have 2 out of 3, 2 out of 3k. Where there is x, then I'm going to put k squared. And so you put k squared, then power 3 over 2, then plus 2, then you have k squared here, now power half, then you have 1 over k squared, and then where there is k, you are putting also k squared. That is that. Then we put minus, and then we put this one here. So we shall have 2 over 3 of k, and then you have a quarter, then power 3 over 2, you see, then plus, this will be 2, then a quarter k squared, then you put a half here as a power, then plus 1 over k squared, and then x here is a quarter k squared. Okay, and then this one we shall equate to 13 out of 12. Now there is something that I actually messed up here. There is a k squared I never put here. Okay, there is a k squared that is missing here. Pardon me. So there is a k squared here. It looks so squeezed. So let me try to shift the whole thing around there. Then k squared. Okay, now let us simplify. 2 times 3 over 2, you get 3, not so? So we shall get 2 over 3k, then times k power 3. Then how about here? It will be 2k. How about here? It will be 1. Okay, Now, this one, I'm going to simplify it, okay? We shall have k squared, not so? So I'll write 2k squared over 3, okay? Then we have, what do we have here? Let me just put this in the calculator. We have 2 out of 3. Then here we are having a quarter, which is 0.25, okay? Then we power it with the 1.5, the 3.2. I mean 3 over 2, not so? That one will give us 1 over 12. So we have 1 over 12 of the k. So I've just simplified this together with this, and then this. Then there is k squared, okay? K squared then times the 3 over 2, okay? And this will be k cubed. So we shall have k cubed there. But then this one will simplify to k squared, okay? So I'll have k squared here. All right. Then next, what shall we have here? We shall have 2 times the square root of a quarter will be a half. So this one goes, and then the square root of k squared then will be a k. So that means we are having a k here. And then how about here? You have k squared going with this, and then you will have a quarter. So we have a quarter here, then which is equal to 13 out of 12. Now, let us simplify this. You have 2 over 3 k squared minus this one here. Now, when you open the brackets, okay, the negative will affect everything there. So minus 1 over 12 of k squared. Then we have the 2k, then minus the k, then 1 minus a quarter. 1 minus a quarter. Then this one is equal to 13 out of what? 12. So what do we get here? 2 out of 3 minus 1 out of 12. You get 7 out of 12. So 7 out of 12 of k squared. Then plus, here we shall get a k. Then here we shall get 3 over 4. Then this one will give us 13 over 12. Now we can multiply all through by 12 to eliminate the denominators. Even 4 goes into the 12. In other words, the LCM of 12, 1, and 4 is a what? Is a 12. Okay, so multiplying all through by 12, we shall get here 7k squared plus 12k, then plus, you have 3 over 4 times 12. This one goes here 3 times, so 3 times 3, don't you get a 9? So plus 9, then is equal to 13. So bring this on this side. That means we shall have 7k squared, then plus 12k, and then 9 minus 13. I think that one will be a negative 4, which is equal to 0. Now we have a quadratic equation in k, okay, which we can solve. So I'm going to put this one on the calculator. Mod, equation is 5, and then quadratic is 3. The coefficient of k squared is 7. The coefficient of k is 12, and then the constant part is negative 4. So this one gives us 2 over 7, and then negative 2. 2 over 7 and negative 2. So I will skip space, and then I say k is equal to 2 over 7, and then k is equal to negative 2. Give us factors from which these roots come. Show the attempt to solve the quadratic equation. So when you cross multiply, that will be 7k is equal to 2. Then we bring the 2 this side. That will be a minus 2 here. And then bring this one here. That will be k plus 2, which is equal to what? 0. So you have shown the examiner the attempt to solve the quadratic equation using factorization. Now you can continue. Now, they said we find the value of k, not values. Now, when you go back and you check here, they said k is a positive what? Constant. You see that? That means from these two, I'm supposed to pick one value, which has to be 2 over 7. So therefore, k is equal to 2 out of 7. That is that. Question 11 is coming from circles. A circle with center C has this equation here, but show that t negative 6, 6 is outside the circle. Now, if I have a circle, okay, I have the center is there, and then there is a point on the circumference of the circle here. Now, this is the radius. If a point is inside the circle, that means its distance from the center of the circle is less than the radius. Then a point that is on the circumference of the circle, its distance from the center of the circle is equal to the radius of that circle. And then a point that is outside the circle, its distance from the center of the circle must be greater than the radius. You see that? So let us first find the radius of the circle. So the radius r of the circle is going to be equal to the square root of 100, which is what? 10. You see that? Let me put, let me try to sketch this one here. The center will be 8, 4. Not so. 8, 4. That is the C. And then T is negative 6. So negative 6 is on the left of the 8. Then 6 is above. So probably, yeah, it is even outside the circle by just sketching. So you put, this is 8 units. Then negative 6 is way like this. And then 6 units. 6 is just above the 4. So T might be around there. So suppose I say this is my T here, which is negative 6, then 6. So we need to find this length here. Is it bigger than the radius? Of course, it is expected to be so. So T, or I can say CT, the square root of, now you have 8, the change in x, 8, then minus 6. That is the change in the x-axis, then plus, the change in x, then the change in y will be 4, then minus the 6. 4 minus the 6 squared. So here we shall have a 14. 14 squared is 196, not so. And then negative 2 here squared will be a 4. So we are getting root of 200, which is the same as, this is root of 100, then times root of 2. So this will be 10 root of 2. Now 10 root of 2 is greater than 10. Therefore, because 10 is multiplied by something here which is bigger than 1. So it has to be greater than the 10. So therefore, T negative 6, 6 is outside the circle. Is outside the circle since its length from the center is bigger than the what? The radius. You see that? So let me actually connect this to that. Then I put this is 10 units. 10 from here to there. That is our radius. So that is that. Then 2 tangents from T to the circle are drawn, but be sure that the angle between one of the tangents and CT is exactly 45. Now, we have a tangent. Okay, so I can have this, and then I draw a tangent like that. Like that. You see? Now, I'm going to duplicate this. then put it down here. So let me take this one away and also this one away. Then I come to this one here that I have duplicated. I'll put it here. Then what are we going to have? They are saying show that the angle between one of the tangents and CT is exactly 45 degrees. Now, we know that the angle in between the radius and the tangent is always 90 what? Degrees. The tangent is always perpendicular to the radius. Not so? Now, what are we going to have? They said the angle between one of the tangents and CT. So this angle here between one of the tangents and CT is 45. Is this one 45 degrees? That is what we want to find out. Now, since this one is a right angled triangle, okay, then we can use SOHCAHTOA, okay? So using SOHCAHTOA, I can have relative to this angle here, this side here is the opposite, okay? And of course, this one is going to be 10, not so. So let me shift this C and then I put it here together with its coordinates. We take the 8 here and then all of this just like that, so that I can put the 10 here. So we shall have sine of theta is equal to the opposite, which is 10, out of the hypotenuse here, the CT, which we have gotten up here as 10 root of 2, okay? 10 root of 2. So this one can go, okay? Then you have sine of theta, which is equal to 1 over root of 2. And then theta will be equal to the arc sine of 1 over root of 2, which gives you 45. So that means theta is equal to 45 degrees, as simple as that. The two tangents touch the circle at points A and B. Find the equation of the line AB, giving your answer in the form y is equal to mx plus what? C. Okay, so I'm going to bring back my diagram here. So I will select this one here and then I copy it. Then I take it the other side. So this is my diagram here. I can let this one be the point A and then this one to be point what? B. Okay. Now, something you need to know about these tangents that intersect at a point outside the circle is that if this one has a gradient m, then this one is going to have a gradient negative m. Okay. They have the same gradient, but they just differ in the signs. Okay. All right. Very important there. So we need to find the equation of the line AB. They want us to find this one here. Let me make it dotted. Okay. Another thing you need to know is that any line that passes through the center of the circle always bisects a chord on the circle. So if I have a circle here, then this is a chord. Okay. This is the chord. Let's say this is B, this is A. Then there is a center here. And there is a line that passes through the center of that circle. It will always bisect that chord. So this and this will always be equal. Why? It is because this one is an isosceles what? Triangle. You see that? So this is R and R. Now, we need to find, it is the same thing that we are going to use here. Okay? Look at this one here. This line here, CT, is passing through the center of the circle. So because it is passing through the center of the circle, that means it is going to bisect this chord AB. You see? But I can find, remember I need the gradient of this line here, AB. But since this one passes through the center of the circle, and I know the coordinates of T and the coordinates of C, I can find that M1. Then I say M1, M2 is equal to negative 1. Then it will give me the gradient of what? AB. Do you see that? So that is what we are going to have there. So let's see. Gradient of CT will be the in uh, change in y will be 4 minus 6, then 8 minus minus 6, 8 minus minus 6. So here you will get negative 2. Then we divide by, this will be a 14. So this one will give us negative 1 out of 7. That means gradient of AB would be equal to negative 1 out of negative 1 over 7, which will give you what? A 7. You see that? Now, for us to find the equation of the straight line, we need to have the gradient, which we have, and then at least one point through which a line passes. So we don't know this point here, B. We don't know this point A here. Okay? We can find them, but it is going to be something very big, because you will need, you don't even know point B or point C. Okay, for you to get the M1, then from there you get the M2. You see that? So it becomes a little bit what? Hectic. Now, there is something you must know. Let me even note it here. For any two intersecting tangents on the circle, for any two intersecting tangents to the circle, okay, the line joining the 2 points, the line joining the 2 points of intersection, so for this case we are using A and B. Okay, the line joining the 2 points of intersection passes through the midpoint of those 2 points. Okay, the line joining the 2 points of intersection passes through their midpoint. Now, I've drawn this one. It doesn't look like this one is going to be the midpoint of C and T. Okay, it is not so perfect. But then we need to find the midpoint. No. The midpoint of T and C. So it has to be, yes, it passes through the midpoint of A and B, and it also passes through the midpoint of these two. Okay, so it passes through their midpoint. In fact, I'm going to say it passes through the midpoint of the center and the point of intersection, and it passes through their midpoint, their midpoint, comma, the center, and the midpoint of T and C. Okay, T and C. The center, it passes through the center and the midpoint of T and C. Yes. So let us do that. So the midpoint of T and C, let me just write the midpoint of TC. Then this one is going to be negative 6 plus 8 divided by 2. And then you have 6 plus 4 divided by 2. What does this one give us? 8 minus 6, that is a 2 divided by 2, that will be a 1. Then 10 over 2, that will be a 5. Now I'm having 1, 5. So I can use y minus y1, which is equal to mx plus c. So y minus the 5 then is equal to, our m is the 7. So this line here has the gradient of what? 7. Okay. and then it passes through the midpoint of T and C. Okay, so 7 then into x minus 1. Oh, what did I write here? This is very wrong. It is m into x minus x1. Pardon me there. Then you take this one this side, you will have y, which is equal to 7x, then minus 7. But then when this one crosses, it becomes a plus. So meaning our answer is going to be y is equal to 7x, then minus 2. That is that. Then lastly, part D, you're saying find the x coordinates of A and B. That means we are supposed to solve simultaneously. So solving y is equal to 7x minus 2, which I've gotten, and the equation of the circle, which was given as x minus 8 bracket squared, then plus y minus 4 squared, which is equal to 100. So I solve these two simultaneously, okay? Because when I solve them simultaneously, you will see that this line now meets the circle at this point B and point A. You see that? So let's go. Now, where there is y, you can use substitution method. So just substitute this 7x minus 2. So that means we shall have x minus 8 squared, then plus, this is 7x minus 2, then minus 4 squared, which is equal to 100. So we have x minus 8 squared, then plus 7x, then minus 6 squared, which is equal to 100. Then you have x minus 8. Now we open the brackets, okay? So square this one here, you have x squared, then 2 times x times 8, that will be minus 16 of x, and then square the minus 8, you get a positive 64. Then square this one here, you will get 49x squared, then 2 times 7 times 6. 7 times 6 is 42, then times 2, that will be 84. So minus 84 of x, and then square the minus 6, you will get a 36. Then bring this 100 this side such that we form a quadratic equation in x. Now x squared plus 49x squared, that one will give us 50x squared. Then we have minus 16 minus 84. Isn't that minus 100? Yes, minus 100 of x. Okay. Now we have 64 plus 36, that is 100, minus 100, that one is a 0. So we shall put this one to 0. Then 50x is common. Then we shall have x here, then minus 2, which is equal to 0. So when I equate this one to 0, then x will be equal to 0. That is one x coordinate. And then when I equate this one to 0, then x will be equal to 2. So those are the two x coordinates for A and B. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.